Hi guys, welcome to another video. In this video, we'll discuss about the characteristics of matter, and in the discussion will include the physical nature of matter. Alright, so if I first talk about the first characteristics of matter, it is your matter is made up of particles. Obviously, we know that matter is made up of millions of particles. Yes, that is the first characteristics. Next. Second one, particles of matter have space between them. Now, what do you understand by particles of matter have space between them? Because we know that the particles will be of millions of particles will be there. So, how will I know that particles of matter have space between them? I'll give you one very good example. Suppose there is a beaker. In this beaker, I am adding 100 ml of water. There is 100 ml of water. And I am adding in this beaker, I am adding sugar. So, once I started adding the sugar, what will happen? And I just stir it. If I just stir it, what will happen? All the sugar particles will be mixing with the water. All the sugar will completely mix with the water. That is, once I stir it. Ultimately, what can I say? Particles of, that is the sugar is there, right, which have dissolved in the water. The particles of sugar is completely occupying the space between the particles of your water, which is present in the whole beaker. So, hence we can say that particles of matter have space between them. Next, particles of matter are continuously moving. What do you understand by particles of matter are continuously moving? A very simple practical example will do, that is, if you remember your agarbattis. Agarbattis is there. Yes. Now what I do, once I start burning this agarbatti, what will happen? Suppose your agarbatti flavor is your rose. Okay. So what will happen? This agarbatti flavor will, that is, when once I start burning the agarbatti, what will happen? The smell of your agarbatti will be surrounded fully around your room. So ultimately, what can I say? Particles of matter are continuously moving. That is, the vapors which is coming out from the agarbatti, those vapors will mix with the air present in your whole room. Ultimately, what happens once the vapors are mixing, the agarbatti's vapors are mixing with your air, what will happen? You will get the whole smell in your room. Therefore, the particles of matter are continuously moving. Alright, particles of matter are very small. This is a very simple lesson which is given in a textbook. Take 100 ml of water, okay, and you are going to add the KMnO4, potassium permanganate. You are adding this beaker of 100 ml of water. So what will happen? The solution will be at the time purple color solution. The solution will be purple color when you add KMnO4 in the 100 ml of water. Now in the purple solution, you take a test tube, and in the test tube you take 10 ml, dip inside the solution, and you take 10 ml. Once you take 10 ml, what will happen? You put in the new beaker which contains 90 ml of water, and you add this 10 ml. Next, what you do, again you take the second beaker, you take it. Again you take from this, you take 10 ml of this solution. Again you add in this solution. What will happen is, if you do this 5 to 6 times, what will happen is, the purple color solution will be converted into light pink color. The purple color solution will be converted into light pink color if you do this 5 to 6 times this experiment. So what can I say again? The particles of matter are very small. That is what, if I in the 100 ml of water, I am just adding 2 to 3 drops of potassium permanganate. So potassium permanganate, if I add just 2 to 3 drops in the 100 ml of water, clearly I can see the color change. Therefore, the particles of matter are very small because the potassium permanganate is having millions of particles. Because of the millions of particles, what is happening? The color change is drastically changing. Therefore, particles of matter are very small. The last one, the particles of matter attract each other. If I take a chalk piece, suppose, and if I take, suppose, a iron nail, okay, so if I want, and if I take a solid ice cube, okay, so if I want to break the chalk piece, it is very easy to break for me. If I want to break a solid ice cube, it is very difficult to break for me the solid ice cube. But if I want to break the iron, it is not possible to break my iron. So with all these considerations, what can I say? Particles of matter attract each other. That is, chalk piece will require very less force of attraction. If I talk about solid ice, if you want to break that, it requires a moderate force of attraction. If I talk about iron nail, if I want to break that, which is impossible, it requires a heavy large force of attraction. Therefore, all over, what can I say? Particles of matter attract each other. That's it.